we need to talk for a moment. And I go back to my examples from last time. These were a substitution. Here it is. Here's an example. So in this situation, we decided to eliminate whatever, and we multiplied both sides of this equation by 5. After we did that, we added the result to another equation to obtain this one. So multiplying any row by a number that is not 0 and adding the result to another row to create a new equation or a new row is the third and the last allowed row operation. So let's put it in writing. Back to the recycle bin. So multiply any row by a number that is not 0 or non-zero number, and add the result of that multiplication, the result, to another row to create a new one. The result here is we create a new row. It's exactly what we did in elimination, but of course it will look different than if we were just eliminating. Okay, so let's go back to our system. And I'm going to copy it again. I'm not going to copy the system. I'm going to copy the augmented matrix. Not before we carve in stone the sequence of steps. Sequence of steps for Gauss-Jordan. Gauss-Jordan method. We know that our ultimate goal whatever number, I don't care, whatever number you want to put in there. So this is our target. Our target is give me any 3 by 3, any system 3 by 3. I will create the augmented matrix, and I will change the augmented matrix into this. But where do I start and where do I end? And here is the sequence of steps. This is the first step. Getting the corresponding zeros of that column is always the second step. Like here, now the third step has to be the 1 of the second column. Then step 4, getting the zeros in that column. Obviously, I got to the third row, column, so this would be the 5th step, and of course the corresponding zeros, 6th step. So one more time, and we cannot deviate from this. Deviating from this sequence will never give us the solution. It will only complicate things, and we will never get there. So one more time. 1 and then the corresponding zeros. Why? Because this number will allow us to eliminate and get the zeros here. The next step, 1, 2. Step 3, get the 1 and then the corresponding zeros. Only this number will allow us to get the zeros. Finally, I shouldn't say finally, step 4, 1 of the next or the last column and then the corresponding zeros. So knowing that, now I'm going to copy. So this was 3, this is 4. I'm going to copy the augmented matrix. And let's start working on it. 1, 1, negative 1, negative 2, 2, negative 1, 1, 5, negative 1, 2, 2, 1. Okay, so remember the sequence of steps. I already have this accomplished. I love it. The first row, first column is already 1. That entry is 1. Now, what I need is to make this disappear and to make this disappear. In the first step, I always use row 1. On the side here, no equal symbol, please. On the side here, I just write what I'm going to do. I'm going to multiply row 1 by something to eliminate this and add it to row 2. Then I go back and multiply the same row by something to eliminate this and add it to row 3. Now let's establish what we need to multiply by. So what should I multiply? Everything, all entries, but my target is here. What should I multiply 1 by to eliminate the positive 2 in the second row and add it to the second row? This is row 1 that is multiplied and then added to row 2. Or row 1 that is multiplied by something and added to row 3. So what do I multiply? Yes.
Negative 2.
Very good, negative 2. What do I multiply 1 by to eliminate the negative 1?
Negative 1.
Just 1, because 1 times 1 minus 1 will be 0. Agreed?
Yes.
I have to multiply by something and it cannot be 0. So in this case, it's 1. Any questions so far? Okay, so let's do that. Do not write equal symbol, please. When I use row 1 or any row, that is the only row that doesn't change. I have to copy it. 1, 1, negative 1, negative 2. At this point, let's multiply. 1 times negative 2. As I have to multiply everything here, but step by step. 1 times negative 2 plus 2.
0.
1 times negative 2 minus 1. 1 times negative 2 and then minus 1.
Negative 3.
Perfect. Negative 1 times negative 2 and then plus 1.
3.
Perfect. Negative 2 times negative 2 and then plus 5.
9.
Perfect. 1 times 1 minus 1.
0.
1 times 1 plus 2.
3.
Negative 1 times 1, but then plus 2.
1.
Negative 2 times 1, and then plus 1.
Negative 1.
Perfect. What have we accomplished? A lot. What is my next step? And this cannot change. This is carved in stone now. If I go back and
3.
yes, so I'm here. I want this to become a 1. What should I do? And I'm going to write here on the side so you see what I'm doing.
Multiply it by negative 3.
But divide. So
divide.
Very good. Row 2 divided by negative 3. Awesome. I copy, oops. I just said that. I just said it. Sorry. I copy 1, 1, negative 1, negative 2. I copy 0, 3, 1, negative 1. And of course, the 0 here cannot change because 0 divided by negative 3 is still 0. Negative 3 divided by negative 3 is 1. 3 divided by negative 3 is negative 1. And 9 divided by negative 3 is negative 3. So what do we have right now? We have this, and this. This number will help us eliminate this, and it will help us eliminate this. It's the second step. I have to use row 2 and add something to row 1. and add something to row 3. So I need to multiply 1 by something to eliminate the 1.
-1.
Perfect. I need to multiply 1 by something to eliminate the 3.
-3.
Perfect. And you understand that after that, we just have to involve 1 to eliminate the zeros, to turn these into zeros, and we're done. So this is basically the second step. There was an intermediate step because I needed to divide by -3. But the major steps are when we multiply R1 and we add to 2 and 3, when we multiply R2 and we add to 1 and 3, and then when we multiply R3 and we add to 1 and 2. But what we accomplished before cannot change. If it changes, then we are not on the right track. Which row do I copy now? It's the one that I'm using, so it cannot change. And it is row
2.
Yes. So 1, -1, -3. Good. So 1 times -1 plus 1.
2. And 0, excuse me.
Yes,
Sorry.
that's okay. We have to get used to this. This is not something you've seen before. I'm assuming 1 times -1 plus 1 is 0. -1 times -1 is 1. Minus 1 is 0. -3 times -1 is 3. But then minus 2 will be 1. 1 times -3 plus 3. -1 times -3 is 3, plus 1 is 4. -3 times -3 is 9, but minus 1 is 8. Can anyone give us x at this point?
X is 1.
That's it. Okay, we're not there yet. We haven't finished. So now, obviously, this is done, but I need a 1 here. 1. How do I get that to be a 1? Because without this, I cannot eliminate. It happens that this is by chance already 0. But I cannot eliminate this if I don't get a 1 in here.
Divided by 4.
So row 3 divided by 4. Awesome. One, 0, 0, 1, 0, 0. 0, -1, 1, -3, and I divide both sides by 4, and I get here a 1, and I get here a 2. What did we accomplish? A lot. Done. Including this. We have one tiny step left, somehow to get a 0 here. Which row do we need to use in the final step? Always.
The third row.
Very good. What do we multiply it by to add it to row 2? Because there is no need to add it to row 1. I already have the 0. So what do I multiply 1 by to add it to -1 so I can get 0 here? Just 1. I copy the third row. 0, 0, 1, 2. That doesn't change. Of course, nothing else changes from what I built already. If it changes, something is terribly wrong. And of course, 0 and 1 already. 1 times 1 minus 1 is 0. 2 times 1 minus 3 is -1. After all this work, finally we can read the triple.
1, -1, 2.
Who knows? Nobody knows. Have to go back to the original system. 1, -1, 2. 1, -1, 2. 1, -1, 2. 1, -1, 2. Let's try. 1 minus 1 is indeed 0. Minus 2 is -2. Yes. 2, but plus 1 is 3, plus 2 is 5. Yes. Negative 1 and minus 2 is negative 3, but plus 4 is positive 1. Yes. It's the only one. I'll say yes. I checked. And this is the method called Gauss-Jordan. Any questions? Any questions? Okay, let's choose the next problem. This one took half an hour because I needed to tell you a lot about it. So now let's choose another. And this is it from chapter 6. That's all we need. There are several methods in chapter 6. We only have to, in 6.1, we only have to use one. Now, if you prefer, if you would like to read Gaussian elimination with back substitution, if you want to use it, fine. This is just half of the method I just showed you. Or you go all the way with Gauss-Jordan method. These are the steps. You don't need to read this unless you have any difficulties in understanding the steps. Okay, so let's take a look. 23. I did not do it earlier. Page 631. And we have x plus 3y equals 0, x plus y plus z equals 1, 3x minus y minus z equals 11. I'm checking. X by 3y, yes. X, y, z, yes. 1. 3x minus y minus z equals 11. Perfect. Let's put this away. It's so heavy. Okay. So the first step, we have to write the augmented matrix. Anyone would like to dictate the augmented matrix for this system, or I will write it?
Would it be going to be 1, 1, 1, 3?
Very good. By columns. Perfect. Because
3,
I should have
1,
mentioned that the system is correctly arranged. Yes. So 3, 1, negative 1.
Would that be 0?
Absolutely.
1, negative 1.
And 0, 1, 11. Very good. Perfect. Where is the starting point? Well, luckily, it's there. Good. And the next step, I need to get the corresponding zeros. I will have to multiply row 1 by something to add it to row 2. And row 1 by something else and add it to row 3. What do we need to multiply this by to eliminate this? But again, as you know, you cannot just multiply one term. It has to multiply everything and add it correspondingly.
Negative 1.
Very good. And for the other one?
Negative 3.
Perfect. Which row I have to copy because I use it. I'm using it and I can change it while I'm using it. I can't change it. No one can change that.
Row 1.
Yes. So row 1 is 1, 3, 0, 0. Good. So then 1 times negative 1 plus 1.
0.
Perfect. 3 times negative 1 plus 1.
Negative 2.
Perfect. 0 times negative 1 is 0, careful, plus 1 is 1. Also 0 times negative 1 is 0, plus 1 is 1. Let's see what we get for the last row. 1 times negative 3 plus 3. It better be 0 because that's what we multiplied by negative 3. 3 times negative 3, negative 9. Negative 9 minus 1, negative 10.
Negative 10.
Perfect. 0 times negative 3 is 0. Minus 1 is negative 1. 0 times negative 3 is 0. And 11. What have we accomplished? We finished with the first column. But now we have to move on. And we're having a little bit of a difficulty because at this point, I have to get a 1 here. And I have no choice. There are other ways, but I don't want to complicate things. So we have to divide row 2 by negative 2 to get the 1 here. So 1, 3, 0, 0, 0. Negative 2 divided by negative 2 is 1. 1 divided by negative 2. And we have to work with a fraction, and the same thing here. And then 0, negative 11, negative 1, and positive 11. This is done, and this is done. In the second step, we have to use row 2.
Why did it go to negative 11 in the third row?
No, I made a mistake. It's positive 11. Sorry, nothing. Oh
no, the negative 10 went to negative 11. Oh, okay.
My goodness. Thank you. No, my mistake. I talk too much, that's why. Sorry, my apologies. No, I can't change anything. This third row is not changed. Just I divided this by negative 2, this by negative 2, and this by negative 2. Sorry, my apologies. So R2 multiplied by something to add it to R1, and R2 multiplied by something to add it to R3. Row 3. So 1 needs to be multiplied by to add here and get the 0, because that's my next target. I want the zeros here.
Negative 3.
Good. And in order to eliminate the negative 10, I need to multiply by?
Another negative 10.
Because this is negative, I need the positive 10.
Okay.
Maybe this was not clear. This is positive 1. Okay. Which row I copy now? Because I'm using it, it can't change.